This is problem number 4B on the sample test problems for test number 3. Peter wants a place to graze his armadillo, so he needs to create a paddock with 500 square feet of space. Being a creative guy, he wants the paddock to have an interesting design, so he has decided that its shape will be a rectangle topped with a half circle. What should the dimensions of the rectangle be to minimize the amount of fencing he will need? So let's start this problem by drawing a picture. It said that we wanted a rectangle topped by a half circle, a semicircle. So the paddock will look something like that. Notice that we don't need to complete the rectangle. You don't need to put fence in there, so that will be an empty space for us as we're doing our calculations. We know that we want to make sure that the paddock has 500 square feet of space, so apparently that's the area of this shape. And we're trying to do it in such a way to minimize the amount of fencing that we're going to need. So it seems like we're now looking for a formula that that tells us how much fencing we're going to use. So let's go ahead and start labeling our diagram here. We're going to put some letters. So let's say that that's a length. Down here we'll call it W for width. Over here is L for length. And it also seems like because there's a semicircle involved, we should talk about the radius. So how about we call that thing R? Okay, so if we want to figure out, again in purple here, the amount of fencing we're going to need, that feels like it's a perimeter calculation to me. So let's write down an expression for the perimeter with all these W's, L's, and R's. So the perimeter is, we have two L's plus, we only have a single W because that the other W is just empty inside of the paddock. And then plus, okay, the word perimeter isn't quite right for a semicircle, but we want a circumference. So we know that the circumference of a circle, the full circumference, is 2 pi r, but this is a semicircle, so we only have half of that. So I guess we'll leave it as a 2 pi r, but then I'll say divide by 2 because there's only half of the circle there. 2's will cancel. So we've got this, but we've got way too many letters here in this on the right-hand side of that purple equation. We're going to want to take a derivative of this perimeter formula, but we can only do it when the right-hand side has one letter in it. So right now we've got real problems. It's got 3 different letters on the right-hand side, a length, a width, and a radius. So the first thing we can do is relate the radius to the width. So it sure seems like, based on this picture, the radius is just half of the width. So how about instead of R, we put half W. So there's our first goal in trying to make the right-hand side have only one letter. So then instead of the radius, we're putting half of W. Okay, so far so good. The right-hand side now has 2 letters. That's better than 3. Next thing we need to do is get rid of one of the other letters, the L or the W. So how are we going to do that? Well, there's one piece of information we've written but haven't used. That's the fact that the area is supposed to be 500. So now I feel like we're going to want to find a formula for the area of that whole paddock, that whole fenced-in area. Okay, so the area is, we've got a rectangle, so the area of a rectangle is length times width, plus, and then we've got a semicircle. So the area of the whole circle is pi r squared. This is a semicircle, so cut it in half. Okay, fair enough. Let's keep playing with this. Area equals L times W plus pi radius squared over 2. Instead of the radius, I feel like we're about to make the same substitution we did before. So the radius, we've already discovered, is really half of W. So if we just put half of W right in here, then that seems to be better. So this becomes half W. All right, that fraction is really getting messy, so let's spend a moment cleaning it up. L times W plus pi. Let's square everything in the parentheses, so it becomes a quarter W squared, and that's divided by 2. And then hopefully we can make that just one nice clean fraction. So let's see, the pi is definitely upstairs, the W squared is definitely upstairs. Turns out that quarter really means there's a 4 downstairs multiplied by the 2 that's already there. Hopefully you get pi W squared over 8. And the last thing that we know is that the area is given in this problem to be 500. So there are a lot of different ways that we can make a paddock whose area is 500, but I know that this equation is going to be true for all of them. So how about we take, it's kind of easy to forget the goal because this problem is so long, but the goal is to make it so that this equation right here has only one letter on the right-hand side. So I'd like to really get rid of either the W or the L. And so what we're going to do is take this equation here and solve it for either W or L. So truth be told, one of them is a lot easier to solve than the other. In this equation that we highlighted last, it's easier to solve for L. There's only one L in there. So let's get rid of some of this highlighting and acknowledge that we're going to solve this equation here for L. And whatever we get, we're going to plug right in there. And then it will only have W's in that perimeter equation in purple. So let's solve this thing for L. All right, lots of algebra here. Subtract that fraction from both sides. We'll get 500 minus pi W squared over 8. And then trying to solve for L, we divide both sides by W. And we get L equals 500 minus pi W squared over 8, all divided by W. Okay, again, it's probably worth some time cleaning this up before we substitute it back in. So how about we try to clean up the fraction within the fraction by multiplying top and bottom by 8. So multiply up here by 8 and then also down here by 8 to try to clear that fraction upstairs. So the 8 is going to come in and hit both terms. 500 times 8 is 4,000. Minus, when the 8 comes in and hits the fraction, it cancels with the 8 that's downstairs. So that's pi W squared. Divide by 8W. So that is about as good as it's going to get for us for L. So all of this is equal to L. Remember, the goal was to take that and plug it in for this L right here. So let's do that. So we're going to rewrite that purple equation, and instead of the L, we're going to put this whole big mess that's downstairs. So we're back in purple, the equation way up above, plus perimeter equals. So it was W plus, I guess I wrote it in the other order. It was 2 times L. Instead of L, we're going to put a lot of stuff. Plus W, this is just copying the rest of the purple equation, plus pi times W over 2. So let's just take a moment and double check that that agrees. Pi times W over 2, I think that's the same. And then this thing in the parentheses is all that stuff in yellow. (4,000) minus pi W squared over 8W. Okay, so it took a long time, but we finally have an equation for perimeter that has only one variable in the right-hand side. Compare that to where we started. The top purple equation on the right-hand side has L and W and R. We did a lot of work. Now on the right-hand side, it's only W. So we finally have an equation we can differentiate. Before we do, we're going to spend a minute just cleaning it up a little bit. So in the first part, the 2 cancels with the 8. That'll make it a 4 downstairs. So let's just rewrite that. P equals 4,000 minus pi W squared over 4W plus W plus pi over 2W. And the goal is to take a derivative. So we can take a derivative right here, right now. You're going to have to use the quotient rule on that fraction. I would prefer to avoid that. You're welcome to do the quotient rule. You get the right answer as long as you follow the rules correctly. But I'm going to do something kind of funny, and that's take this 4W and split it up and make 2 fractions with a 4W underneath. So the first fraction is a 4,000 over 4W. Second fraction is a pi W squared over 4W minus sign in the middle. The only reason that worked is that the 4W that was there in the bottom is one term. It's just multiplication. And then we'll copy the rest of this, plus W plus pi over 2W. And then one more thing simplifies. We can go ahead and cancel one of these W's here with the W that's downstairs. So last rewrite, and then we finally get to take a derivative. Hooray. Oh, I guess 4,000 and 4 cancel as well. So we'll make that 1,000 over W. Oftentimes, the hardest part of the calculus problem is the algebra. And I think that's the case in this problem. Okay, we've got an equation for the perimeter. It has only one variable on the right-hand side, w. And finally, it's as clean as it's going to be. So let's go ahead and take a derivative and put it up here. P prime equals derivative of 1,000 over w. You can use the quotient rule. It's pretty quick. You can rewrite it as 1,000 times w to the -1. Or if you remember that shortcut that I shared with you way back when, the derivative here is immediate. It's minus the constant over w squared. Minus. And now we're looking for the derivative of pi w over 4. And the derivative of that, again, you can use the quotient rule if you wish, but if you see that it's really just pi over 4 times w, then the derivative is just pi over 4. Plus, moving along, we're now up to this term right here. Derivative of w is just a +1, plus, and then the last one, derivative of pi over 2w is just the constant, plus pi over 2. Okay, so that's our derivative. You're welcome to try to combine like terms and clean it up a little bit if you wish. Ultimately, we're going to bail out at some point pretty soon and start using the calculator to get decimal approximations. I'll go a little bit longer before I use the calculator. We'll take the derivative and set it equal to 0. So I'm going to move the w squared term over to the right-hand side. So it becomes positive 1,000 over w squared. Left-hand side in my mind is just some decimal. I'll use the calculator in a minute. But in order to solve this equation, I feel like I need to multiply both sides by w squared to get that w squared out of the bottom. So we're going to get w squared times this whole big mess. Again, it's just going to be a decimal. And the w squared goes away on the right, so it's just equal to 1,000. So to solve for w squared, what should we do to both sides? Divide by that mess in the parentheses. And then finally, to solve for w, we take the square root of both sides. Technically should be a plus or minus because we took a square root of both sides of an equation, but we're looking for a positive width anyway, so we'll ignore that technicality. And okay, we've held out as long as possible before using this calculator. So let's go ahead and very carefully type that in. If it frightens you to type it in one shot, then do it in pieces. So for me, we've got 1,000 divided by, and then parentheses around the bottom, negative pi divided by 4 plus 1 plus pi over 2. So if I've typed that correctly, we should get the answer that matches the thing in the answer key. And that looks good to me, so about 23.67. And then in order to find the length of the rectangle, that's the width, all we have to do is plug the 23.67 somewhere. And the best place to go is the equation that says L equals. So in the top right, this yellow highlighted thing, that's what we're going to use. So I'm going to plug in, instead of W in that equation right there, this equation right here, we're just going to plug in 23.67 for the W. So let's do that down below. So we know that the length is, so that equation up there, 4,000 minus pi times W squared divided by 8W. And the W that we just figured out is the 23.67. So we'll put that in both parentheses. And I know I'm a stickler for this, but we want to make sure we get the most accurate answer the calculator can give. So how about we store this thing? Maybe we can call it W. So alpha W is here. And then we're going to type that fraction in. Very careful with parentheses. 4,000 minus pi times alpha W squared. And then close parentheses divided by more parentheses 8 times, and then that's into alpha W. So if we've done that correctly, we should get the value of the length, so 11.833. And so here we've got our width, and here we've got our length. Technically, we should just double check to see that this indeed gives us the minimum perimeter, because all we know is that we found a critical point, and it's quite possible that that critical point right there doesn't minimize the amount of fence, but actually maximizes the amount of fence. I'm not going to go through the details here, but you'd want to do either a first or second derivative test to verify that that's actually a minimum. In this case, it turns out it is.